take a look at how we do percentile calculations. Now, we're going to spend a minute here or two looking at how we do it by hand, but technology will do this for us. But highlighted here is, and we'll see this right now, is there are many ways to calculate percentiles. There's not one standard method, even though we present one to you. So if you go to different calculators sometimes give in different values. But most important is the idea. What is a percentile, right? And why we use percentiles. What information can we learn from them? So depending on the method, it doesn't change that much the interpretation, because many times we're talking about large sets of values. And so a percentile, to find it, first you need the data in order, like you see in example 2 from least to greatest. Then you count the number of values less than your value that you're thinking about. So for example, if you're whatever X you're thinking of, whatever value, a percentile is the number of values, right? Its percentile is the number of values below that value divided by the total number of values times 100%, and we'll look at that. So for example, again, that's our definition. Certain calculators do a little bit more technical definitions because they have a calculator, but this is us thinking about it. So here's the values. Find the percentile of a bowler in a league who scored 150 points. So here's all the different data values of points. There's 150. You count how many scores are below that. That's 8. 8 out of 32 times 100, you get 25. So we would say 25% of the scores are below 150, or 150 is the 25th percentile, or we would also call that Q1, the first quarter. 240, same idea, there's 240, and then you count how many score below that. You get a value times 100. I get 59.37, so we would round down to the nearest percentile. Again, it's just an approximation. We got an idea that 240 is the 59th percentile. 59% of the values are below it. So it's something to think about, again, as we do the calculations. I don't want you to get caught up too much. I'm going to show you how this looks on technology. So what you see here is the ArtofStat. This is the software we're going to use. We're talking about quantitative data, so this is what you would click on. And when you click on that, it will take you to a screen like this. And what we see is I already have the data in. You'll see this here, exploring. Let me get it on the screen. You're exploring quantitative data, describing and exploring quantitative variables, single group. Again, there's more videos on this, but we're using our own data. You would have to click there, but I have the scores in here already from our note sheets. Here are the scores. And so what you see in the ArtofStat, which is powerful, let's see if I could zoom in a little bit better. What you see in the ArtofStat here is the data. You can pick the different types of plots, dot plots, box plots, histograms, right? That's what we're looking at. And so when we analyze that, you'll see here, I got to make the screen, you'll see the different. And the one we're going to learn in this lesson is box plots. And what you see here when I hover it over, you take a look, you'll see the min, the Q1, the median, Q3, and max. So that's where the quartiles come up. Those are the Q1, the Q2, and Q3. So technology will give us that answer. But if you notice from the data, and here's also a nice little distribution, a histogram for it. And then the box plot also is a distribution of the same data, just a different meaning. You will see the Q1 that we got was 150, and we'll double check. Here you see it's 142. So the computer is doing a slightly different calculation. Either one will be right if you did it by hand or using technology. So I want to make sure you're aware of that. But as we do that again, it's real simple to use. You'd end up using this. You could change the widths for the box. So I wanted to show you this here. But you would hand enter the data into here. That's only one, or you can copy and paste it if you have access to data that way too. So coming back to the actual data, you notice the ArtofStat gave us 142. Again, it's just the ArtofStat is using a different calculation to do it, but you could see it's kind of finding the middle of 134 and 150, which is 142. Here we use the literal definition here and just said how many values are below. They're very close, and many times those values be close, but don't worry about as long as you're using a proper technique, or technology, you'll get credit for these things. Example 3 and 4, let's look at example 3 real quick to end this video. Here's a distribution, a dot plot, and then you see questions here. Based on this 40 students here, right, what would the percentile be if someone has 5 siblings? So this is data about how many siblings students have. Here's 5, right? So here's the number 5. How many people are below that? There are 34 dots below it. If you count those, you could individually count those, and you get 85%. So P85, the 85th percentile is 5. 85% of students have less than 5 siblings. And then you can answer questions here. If we know 65% of the students of 26 students, which number of siblings would you estimate the 65th percentile to be? So here is 26, right? 26 students. Which number of siblings would you estimate the 65th percentile be? It turns out to be 3, right? Because 65% of the students have less than 3 siblings. Think about that, okay? As we think about it, it's kind of awkwardly written question, but it's trying to just get to the idea of what is a percentile. And which number of value would you estimate to be Q2? Q2 is the center, right? It divides the groups in half. Half are below this, half are above. And since there's 40 here, you count 20, and it looks like 2 is the 50th percentile, or the median, right? The Q2, because half this are kind of right in here, go below that, and half above that. Again, it's not exact, it's about an idea. Like, okay, 2 is around the middle. Most students have 2. And then go ahead and read that. Take a look at the discussion. Like I said, that one application of percentiles. You can go ahead and see here. What does it mean? 80th percentile, 60th percentile, and so forth. And that's one application of percentiles in the world.